Okay, so we're going to do 15.20. So we are given a demand function QF equal to A minus BP. So part A asking you to confirm the price elasticity of demand equal to BP on A minus BP. Okay, so elasticity, the price elasticity of demand is found by using the formula epsilon equal to the change in Q given the change in P times P divided by Q, okay, which is QF in this case. Alright, so given Q equal to A minus B P, so if you differentiate Q with respect to P, you will get negative B, okay, and times P divided by QF, and QF is just A minus BP. So that is just negative BP divided by A minus BP, okay, which is what the question asking you to prove. Now obtain the inverse demand function, the average revenue function, and the marginal revenue. Okay, so inverse demand function is just going to be the demand function with P as its subject. So if you rearrange this demand function over here, so I got QF is equal to A minus BP, so then therefore BP is A minus QF, and so therefore P is A minus QF, everything divided by B. So I got A on B minus QF on B. Okay, so this is the inverse demand function. Now I want to find the average revenue. Okay, so average revenue is found by taking the total revenue divided by the total quantity. Okay, so first of all I find the total revenue function first, which is equal to the price times the total quantity. Now, using the inverse demand we found earlier, where price equal to A on B minus QF on B, and everything multiplied by QF. So if I expand the bracket, I got A on B QF minus 1 on B QF square. So from here, it should be straightforward to find the average revenue, which is just going to be equal to the total revenue divided by the total quantity QF. So that will just give me A on B minus 1 on B QF. Okay? And find the marginal revenue. So that is just going to be the differential of the total revenue with respect to quantity QF. So if I differentiate the total revenue function over here with respect to QF, I get A on B minus 2 on B QF. Okay, and it's asking you to draw all of these on a diagram. So we're just going to have a little diagram again. Okay, where I would just have average revenue, marginal revenue, and the demand function P on the diagram, where I got QF on a horizontal. Okay, so now, so average revenue, as you can see, it's exactly the same as the inverse demand function, okay, and it's just a linear function of QF with a vertical intercept of A on B and the slope of negative 1 on B. So I just have to draw a very random one. I know that it's downward sloping because the slope is negative 1 on B, okay, so therefore I just have to draw a very random one, just like this. Okay, so this is my average revenue with the vertical intercept of A on B, and that is just going to be the inverse demand function P as well. So the second one is marginal revenue. Now, as you can see, it again is just a straight line, downward sloping with the slope of negative 2 on B and a vertical intercept of A on B. Okay, so now horizontal intercept for this one. So I got my average revenue curve, is A on B minus 1 on B QF. Okay, so therefore vertical intercept is where I make QF equal to 0, then average revenue equal to A on B. Okay, and horizontal intercept is where I make average revenue equal to 0, and so therefore I found that QF is going to be equal to A. So that is the horizontal intercept over here. Alright, so very similar for the marginal revenue, which is equal to A on B minus 2 on B QF. So vertical intercept again, where QF equal to 0, marginal revenue is going to be A on B, so at the same vertical intercept. And horizontal intercept is where I make marginal revenue equal to 0, so therefore QF is going to be equal to A on B divided by 2 on B, so that is A on 2. So if I go up to the graph over here, you can see that the marginal revenue is going to have the same vertical intercept with the average revenue. However, the horizontal intercept is at QF equal to A on 2, which is equal to half of the horizontal intercept on the average revenue curve. Okay, so it's A on 2 over here, and so my marginal cost curve is going to be this. Okay, sorry, marginal revenue. All right, so part C asking you to confirm that if the marginal revenue is bigger than 0, then the price elasticity of demand is going to be smaller than -1. Okay, so we have the marginal revenue is equal to A on B minus 2 on B QF. Okay, and we want this to be bigger than 0, which is given to us. Now our price elasticity of demand we found in part A is equal to negative BP divided by A minus BP. So if I want to, so if I express P as a function of Q and sub that back into here, okay, so if I'm using the inverse demand function where I know that P is going to be equal to A minus Q on B, there's going to be A on B minus 1. Okay, I just do A minus QF and everything divided by B. Okay, so this is my inverse demand where P equal to A minus Q on B. Okay, everything divided by A minus B times P, and again, it's just going to be A minus QF, everything divided by B. So if I simplify this, now B over here will cancel with B over here on the denominator. So what I'm left with is negative A minus QF divided by, again, this is B, cancel with B over here. So I got A minus QF. All right, so that will just give me negative A minus QF divided by A minus A is 0 plus QF. Okay. Now, so this is basically just negative A on QF. Negative become plus, so plus QF divided by QF, which is going to be equal to plus 1. All right. So now we are using the fact that the marginal revenue is bigger than 0. Equal to A minus B, A on B minus 2 on B QF, and that is bigger than 0. Okay, so therefore A on B is going to be bigger than 2 on B QF. Okay, now I can cancel B on both sides of this inequality without changing the equal sign, without changing the inequality sign, because B is just going to be a positive constant. So therefore, A is going to be A is going to be bigger than 2QF, and so therefore QF is going to be smaller than A on 2. So I would have A on QF is bigger than 2, okay? So therefore, if I multiply -1 to both sides of this equation, I'm going to get negative A on QF. It's going to be smaller than -2, so it's going to change the sign of the inequality, okay? And if I plus 1 to both sides of this inequality, then I'm going to get it smaller than -2 plus 1, which is equal to -1. Now, as you can see, this expression over here is just this, which is the elasticity, the price elasticity of demand. And so therefore, we have already proved that the price elasticity of demand is smaller than -1. Okay, so part D asking you to use the result from part C, confirm that if the firm is maximizing profit, then the price will be bigger than A on 2B. So we know that the monopoly is going to be maximizing its profit if it's producing on the elastic part of the demand curve, okay? So where the elasticity of demand is smaller than -1, which is the condition that we found over here in part C, okay? So I'll say monopoly will maximizes okay its profit by producing okay on the elastic part of the demand curve, or at the point where the elasticity of demand is smaller than -1, okay? So if it's smaller than -1, for example, like -2, -3, then we say that the elasticity, the demand is elastic, okay? And so therefore, that is the part where the firm is possibly maximizing its profit. Okay, so therefore, now elasticity of demand, as we found earlier, equal to -BP divided by A minus BP, okay? And so we want this to be smaller than -1. So if we multiply -1 to both sides of this equation to get rid of a negative sign, then it's become BP on A minus BP bigger than 1. And so if we multiply A minus BP to both sides of this inequality, knowing that A minus BP is assumed to be positive, okay, because it is a demand function. So this thing over here, we know that it's just equal to QF. If you're looking back at the demand function, A minus BP is just equal to QF, okay? And we assume that we're only dealing with non-negative quantity, okay? So therefore, this thing is going to be bigger than 0. So therefore, if we multiply both sides of the inequality by this amount, it won't change the inequality sign. So it's become BP is bigger than A minus BP. Okay, so if I move BP to the left hand side, I got 2BP bigger than A, and so therefore BP is going to be bigger than A divided by 2B. Okay, so the price for the firm is going to be bigger than A on 2B, and this is the price that is required in order for firm to be possibly maximizing its profit.